Can you solve this math challenge? Here's the question. Evaluate this infinite series 1 plus 1 over 5 minus 1 over 7 minus 1 over 11 plus 1 over 13 plus 1 over 17 minus 1 over 19 minus 1 over 23 plus so on and so forth. You can pause this video if you want to give this problem a try. And now, let's answer this question together. To answer this question, let's observe something. So first observation, we have a lot of odd numbers. 5, 7, 11, 13, 17, 19, 23, and so on and so forth. Also, we have alternating signs. We have positive, negative, negative, positive, positive, negative, negative, positive, positive, and so on and so forth. Now, also notice that there are some odd numbers that is not present in the sequence. For example, we don't have 1/3. Also, we don't have 1 over 9. We don't have 1 over 15 and 1 over 21, and so on and so forth. Now, what we're going to do here is to add those numbers. But we need to be very careful here because we need to take note of the signs of 1/3, 1 over 9, 1 over 15, and 1 over 21. The reason is we need to take note of these alternating signs. So let's have this 1/3 as negative, positive 1 over 9, negative 1 over 15, and positive 1 over 21. Now what we're going to do here is to add those numbers to our expression right here. So we have now 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus 1 over 9 minus 1 over 11. Still odd numbers are present. All odd numbers are present, and we also have alternating signs. Positive, negative, and so on and so forth. Now, since we add those numbers to make it balance, we need to subtract all those numbers. So, we need to subtract negative 1/3 plus 1 over 9 minus 1 over 15 plus 1 over 21, and so on and so forth. And now, let's focus on this expression right here. What will happen if we factor out negative 1/3? This will give us negative 1/3 multiplied by 1 minus 1/3 plus 1 over 15 minus 1 over 7 plus so on and so forth. Now, negative of 1/3 is just positive 1/3. Now, here comes the fun part. Take note that these two sequences are the same. So, we can write this as follows. 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus so on and so forth plus 1/3 of the same thing. Now, take note that it is multiplied by 1. So, if we combine them, this will give us 1 plus 1/3 or simply 4 over thirds multiplied by the whole thing. And now, our original given is trimmed down into 4 over 3 multiplied by 1 minus 1/3 plus 1 over 5 minus 1 over 7 and so on and so forth. Now, to have a better view on this sequence, let's add more terms like this. And now, finally, to answer this question, recall the Taylor expansion of arctan of x. Because arctan of x is equivalent to x minus x cubed over 3 plus x raised to the 5th power over 5 minus x raised to 7 over 7 plus x raised to 9 over 9 minus and so on and so forth, wherein x is between negative 1 and positive 1. Now, what will happen if we let x equals 1? So we have arctan of 1 equals 1 minus 1 cubed over 3 plus 1 over raised to the 5th power over 5 minus 1 raised to 7 over 7 plus 1 raised to 9 over 9 and so on and so forth. Now 1 cube, 1 fifth, 1 7, 1 raised to 9 is the same thing as 1. And now this is the same thing as this sequence right here. 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus 1 over 9 and so on and so forth. So, this expression right here is equivalent to just 4 over 3 multiplied by arctan of 1. Now, arctan of 1 is definitely equal to pi over 4. Now, 4 over thirds times pi over 4 is the same thing as pi over 3. Therefore, our answer to this question, what is the value of 1 plus 1 over 5 minus 1 over 7 minus 1 over 11 plus 1 over 13 plus 1 over 17 minus 1 over 19 minus 1 over 23 and so on and so forth? And our answer is pi over 3. And as always, we are done.